Like almost that easy. Almost. Like one little extra step that's like not even like a real step. Well, that's why we're going to review. So first step is to isolate y. Second step, we're going to graph using slope-intercept method from last semester, which I'll review. 3, 4, 5 are the new quick little steps. So step number 1, isolate the y. How do I get rid of 2x? Minus 2x. Divide by negative 3, divide by negative 3, divide by negative 3. Oh, but wait. What's the little thing I told you about inequalities and negatives? There was some little thing there. Okay, so I'm just going to do that in red so that that sticks out. What do I do with negative 2x divided by negative 3? Yeah, just 2/3, because that's going to be our slope, so we're okay with it being a fraction. And then positive 6 divided by negative 3? Minus 2. So just going back quickly to last semester, y equals mx plus b. We start with the b. That's not clear at all. What is b defined as? The y-intercept. So I'm going negative 2, putting a dot. There's our first point. And the second step is the m, and what does m represent? Slope. And slope, we talk about rise over run. You should have heard that last semester. What does that mean, rise over run? Yeah. So it's the vertical displacement over the horizontal displacement. So what does a slope of 2/3 mean? Up to over 3, put a dot. So there's the quick review from last semester. Y equals mx plus b, put the b, count the slope, put a dot. Don't join them yet. So because last semester it was an equal sign, we did it with a line. This year we have to do it a little bit different with the inequality. If it has the or greater to, so either less than or equal to, I meant or greater than or equal to, that's called a solid line, so what you did last semester. If it just has the less than or greater than, we use what's called a dashed line or a broken line. So a solid line means the points on that line are part of the answer. A broken line means they are not. So that's why I said hang on joining this, because we need to go back and look at the sign. Does it have the or equal to? So we're going to draw this with a dashed line or a broken line. Now, because an inequality has a million bajillion solutions like we talked on Friday, we're actually going to do some shading. If it is greater than or greater than equal to, we're going to shade above the line. Because we know greater than means above from what we did Friday. If it's less than or equal to, we're going to shade below. And we need to go back to if we've changed the sign, so not necessarily the question. Because of this division, it's going to change our sign. So we have a less than, so we are shading below the line. Here's how we shade. That's it, just some lines. You don't need to color in every section of it. That'll take forever, especially if you're using a pen. So that's it, just some shading marks tells me that you understand all the solutions are in that area. The second part of the example says state one solution. Pick any point in that shaded region and write it down. So I'm going to pick, I don't know, 6, -5. Give me another point in the solution. So 2, -2, yes. Give me another one. 5, -2, yes. Give me another one. -8 and 3. 3, -8, yes. Give me another one. How long could I keep playing this game? Forever. There's your first linear inequality. The only thing that's different than what you did last semester with lines is you need to decide if it's a broken line or a solid line, and if the shading is above or below. That's it. It's the only thing that's different. Step 1. Okay, how do we get rid of the 3x? Ooh, divide by what now? Okay, step 2 is just get, how do we get the hoo-ha?
How do we get the -1?
What's in front of the y that we don't see?
Oh, yeah.
-1. Now we're just going to put those 2 points using the b and the m. What's the b value? Which is -2 again. What's the m value? 3 over imaginary 1, which means we're going to count up 3 and over 1. Now what's going to happen is, because you did so many lines last semester, you're going to grab your ruler and you're just going to join them. So you need to pause and just think, what kind of line am I using? Solid line or broken line? Broken because it's not or equal to. No, remember we called it dashed in the last one? Dash broken, same thing. That's right on step 3 in the notes. Now we just need to do the shading, which is my favorite part because it's like color the numbers. Above or below, and how do we know? Oh, that was so awesome, that rocked. How do we know? Because it's greater than. Well, what does above mean when it's like this? It means a physically on top of the line, so where it's the point sitting on top, that section in there. Again, you don't need to color it all in, just doing some lines like that tells us you understand. Show me a thumb. How are we doing so far? Getting it? Getting it? Getting it? Good. No. Oh, the other part, right. Determine if the point -5, 3 is a solution. How do we know? Find it on the graph. -5, 3. Is it in the shaded area? Yes, it is. Above the line.
Well, yes, but I mean, like, in the spaces or on there?
It doesn't matter. Either or.
Okay, because then 5 over 3 isn't like on.
But it's that whole area that's shaded.
But that's not shaded. That's what I'm getting at there.
You're overthinking. So the lines mean shading, so it means this entire area in here is shaded. We just get lazy drawing it. It's all of that area. We just get really lazy. So if you want to shade the whole thing in, shade the whole thing in. Does that make more sense?
Yeah, I think so.
Okay, I'm going to show you some cool stuff your calculator did that you didn't even know before. What I want you to do is show me your hands. I don't want you to write. I don't want you to touch your calculator. I just want you to watch, and then I'll back up and do the whole thing. You don't have to keep them up like this, jazz hands. No, just watch me, because if you're trying to do it at the same time, you're going to get lost, and people will be like, what's going on? So I'm just going to show you some cool stuff about your calculator. And then I promise I will back it up and redo it. So let's just graph a line. I don't know, give me any line. I don't know, 4x minus 2. And zoom standard. Boop, there's a line. So I'm going to go back into the y equals. And this is the old operating system. If you have the new, I'll show you something in a second. Is over here on the very left. You probably never even noticed this little line here before. What I'm going to do is tab all the way over to the left. And I'm going to hit enter once and watch what happened. It changed into a thick line. So you actually have an option for graphing is you can have a thin line or a thick line. What's the purpose of that? Well, sometimes when you've got two really complicated graphs, you want them to look different. So sometimes in grade 12, we'll do one thin and then one thick just so we can tell which is which. And so I'm going to go back into the y equals, and I'm going to tab over again. I'm going to hit enter again. So this is now the equivalent of hitting enter 2 times. What happened? Okay, little triangle pointing up. That's your greater than shading. Didn't even know your calculator shaded, did you? I know, how cool is that? So enter once gives you thick line, which you won't use till next year. Enter twice gives you the greater than shading. What do you think enter 3 times is going to do? So arrow pointing down, here's your less than shading. Ooh, ah, isn't it pretty?
Love it.
I'm going to hit enter 4 times. What is that?
It looks like a key.
Watch this. It's a rolly ball.
Oh, it looks like a key.
Why do you need a rolly ball? I have no idea. I never use rolly ball. I don't know rolly ball. I have no idea. I've never looked at rolly ball. I don't know, but it's a rolly ball. Wait, don't, you're not touching. Put your hands in the air, girlfriend. No. No, you're touching. I'm going to go again. Now this is the equivalent of hitting enter 5 times. So 1 was a thick line, 2 was the greater than, 3 was the less than, 4 was the rolly ball. So here is 5. No, rolly ball with nothing left behind. I don't know. I have no idea. I have no idea why you want a rolly ball and have nothing left behind. I have no idea. I'm going to do it again. I'm going to hit enter a 6th time. What do you see? Okay, look. Oh, dotted line. Here's the problem. It can't do dotted line and shading at the same time. It can't do it. Calculator's not that smart. So we never actually use the dotted line. The only time sometimes in calculus we'll use it to have a thin, a thick, and a dotted just to tell the difference, but we don't really use it. Okay, 7 times. What do you think is going to happen? It goes right back to normal. Those are your choices. Regular line, greater than, less than, rolly ball with line, rolly ball without line, dotted line, back to normal. So the ones you care about are the greater than, less than. That's all we're going to use this. But if you want to play with rolly ball, play with rolly ball. So let's put in 4x minus 2, and let's just play with rolly ball for a bit, and then you'll get bored with it. Now, if you have a TI-84 silver and you come to this screen, you might already have less than greater thans on the bottom. Okay, if you don't worry what I'm talking about. If you do, let me know because I'll tell you how to use them. Okay, we're all good then, so we're all doing this. So you can just scroll through, so you can do your greater than or your thick line. Just play with this, get it out of your system, and then you won't care about rolly ball anymore.
I will love rolling.
It's fun at first, and then you're like, what is the purpose of that? What? Yeah. Oh, I know. Oh, rolly ball, yeah. Woo. It's like, what? I have no idea what they use that for. I don't know.
It's probably just to put some fun.
Yeah, I don't know.
Like the game.
See, and rolly ball with no line, I don't know what that's for. I don't know.
Imaginary.
I don't know.
I want to know what it looks like on a graph for the purpose of calculus, so I think that rolling ball is cool. So I think that ball's kind of pointless.
Maybe it's to calculate.
Yeah, I don't
You're
know.
supposed to do the ball.
I don't know.
Throw the ball.
I like the shading thing.
I do like the shading thing. It's pretty cool.
It's like artistic. Yeah, it makes my calculator worth the $120 I spent on it. Yeah, why are these so expensive?
I have no idea because really technology has come so far and the price has never dropped. My guess is because they can.
Is there a point where if you do it too many times, it's gonna break?
No.
Okay, good.
So here's, for example, where we might use a thin and a thick. So later on when you got 2 different functions, you're like, oh, what's going on? We might want a thick one in there. Yeah, I just don't get it. And if you just clear them, it goes back to regular old lines. So if you don't have to flip all the way back, you can just clear and it goes back. So let's just jot down some notes so we remember that. Okay, so using the calculator. So y equals like normal. If I say move to the left, is that going to make sense? Go to the left, pad to the left, move to the left. Go to the left. So for greater than or greater than and equal to, you're hitting enter twice. For less than or less than equal to, you're hitting enter 3 times. And we're just going to put a star and asterisk. Be aware of dash, dotted, whatever you want to call it, versus solid lines. Okay, you need to draw those. The calculator can't do it all for you. So when you're drawing it out, you just have to understand if it's dotted or solid. So let's just practice with example number 2. I'll flip back so you don't have to. So we're going to do this greater than 3x minus 2. Okay, so 3x minus 2, ooh, not in y2, y1. Go all the way to the left. Enter 2 or enter 3? 2 because it's greater than. And you don't need to tab back now. You can go right into zoom. And what do we pick for a normal boring line? Zoom 6. So pretty. Pretty that is.
I love it.
Yeah, it kind of is, yeah. Like a striped referee or something.
I don't really see it.
I don't know.
Again,
With really, really small bars.
So you don't get out.
It's like math class, like prison.
you don't get it in a regular wall.
Next example, we're just going to go backwards. So here's the graph. You give the equation. Okay, so pretend the shading's not there. How did you do this last semester?
Look at all the
Okay, look at all the points. We want to get the slope, so we need slope and we need the y-intercept. Okay, so we need to probably mark some points first, maybe? What points would you like to mark? Give me some names. Oh, I heard it y-intercept. We probably want to mark. And the x-intercept are the 2 easiest. You can mark any 2 points. It's just that gives you b right away. So we know b is 2 with a question mark on the end. M comes just from counting between, so we need to know how many did we run, how many did we rise, so it's actually just counting. It's up how many? 2 and over 1. And so if we reduce, that's just 2. So we have y. I'm going to leave out the inequality sign for now, and I'm just going to fill in mx plus b. Okay, so nothing new from last semester. This is exactly what you did. You just would have put an equal sign. All we're throwing in is the inequality piece. Is it greater than, less than, greater than or equal to, less than or equal to? How can you tell? So if the shading is above, it's greater than. It's a solid line, so it is or equal to. So let's just make a note where those came from. That's because it's a solid line. And this is because the shading is above. Correct.
So does that go on forever?
Mm-hmm.
2 billion?
Mm-hmm. 2.5 billion, yes. Come on, admit it, rollerball was kind of fun.
Oh, yeah.
Infinity times 2.
Catch it like volleyball.
All we're doing for the next 2 is just taking some real life situations and turning them into inequalities. Okay, so the situation in 4, just read to read, don't overthink, sentence in a book. a really big bag.
Is it really?
Yeah, it's like a family-sized Dorito bag.
Is the pop one of those 2-liter pops?
It's like a 550, like a regular, you know.
You can get 99 cent one of those 2-liter.
It's a can. It's a can. It's a really big can. A really big can.
I want to see this.
Yeah. So what's important in here?
$12 money.
Can he spend more than that?
No.
Could he spend less than that? And that's why it's an inequality, because he can't spend anything more, but he can spend less than that.
Can I spend more to save up his money?
Let's assuming he's a bad saver, because he's buying chips and pop, really. No. Chips, $2 a bag. Pop, $1 a can. All possible combinations.
Oh, if you get Matt, goodbye.
No, I don't really care. I don't care if it's Matt, Tim, Bob, I don't care. Mathematicians, we're not about the people. It's irrelevant to us. We're about the numbers. Not to a mathematician. Not so much. No, that's what social sciences are for. Yeah, not us. We're not about feelings. So I'm going to start with some variables. And just like with max min, if you introduce variables, you have to define them. So what would you like to call x? More specific? Not the value, but what about chips? So the number of bags? Why can't we just write chips? Well, does it mean the number of chips? Does it mean their size, their grams, the amount that they weigh, the price, right? So chips is a little too generic, a little more specific, number of bags. What would you like to call y? And we could have flipped that. We could have called x number of cans, and we could have called y number of chips, whatever. We could have used a and b, don't care. They're just variables. Now let's talk about the money, because that's what the economics or the economists care about, and I am an economist and a mathematician, so it's all about money. How much for a bag of chips? So 2 times x. We don't know how many x's he buys. I don't care at this point, but each one's going to cost me 2. Obviously plus, because they're not giving it away, so I have to add it on. Now I'm going to write the imaginary 1, because it's $1 for every can, which we called y. Not equals. So it has to be less than or equal to 12. Why less than or equal to 12? Because he can spend less, he just can't spend any more than that. Now we're just like example 1 and 2. Once we have the equation, we don't care about anything else. How do I graph this? Yes, isolate y. How do I get rid of the 2x? Oh, flip the sign, not flip the sign. I love you to no, don't do that. Why do we not flip here and we flip before? We're not dividing by a negative, we're just subtracting, and subtraction is a-okay, so this is still less than. Okay, how do I graph a line? Damn, 12's not on my graph. What do we do then? Yeah, we'll just add it on. Sorry, left brains, I know this bothers you. Righties don't care, it's a left brain thing. I know, I'm with you. Oh, I'm sorry. Okay, how do we do the slope? It's -2 over imaginary 1. 2 down and 1 over. Ooh, don't draw the line yet, because what do we need to think about? Is it solid or is it dotted, dash, broken, whatever you want to call it? How do we know it's solid? Because he can spend exactly 12. That's okay. He just can't go over. We're assuming taxes included. It has a thing. Yes, so that means it's solid. Do we sell real chips here? I don't think so. Like cardboard chips, that's it. Bless you, bless you. Bless you. Bless you. Now, because this is situational, we call it contextual, because it's not just the numbers, there's a context. We need to be a little bit careful with the shading. Is it going to be above or below? Below. So it's going to be in this area. However, could we buy negative chips? Could we buy negative pop? So I'm not going to shade everything under here. Which quadrants am I going to ignore? Going to ignore 2, I'm going to ignore 3, and I'm going to ignore 4. Quadrant 1. So I'm just going to shade quadrant 1. Again, if we didn't have this situation and this was just a regular equation, I would just be shading everything under there. But because of the situation, I'm just restricting it to quadrant 1. We're assuming tax included, I said.
Like we're in Germany, it says right on there.
Well, all of Europe. It's just, you pay what you pay. It's awesome. And they don't do cents. Like, it may be like 11.50, but they would never do like 11.37. Never. It's only North America. We love our cents. Yeah, but it would be like 11.50 euros. It would never. They'd never deal with pennies and quarters and.
They don't deal with money.
No. The only thing is here we know exactly how much we're spending in tax there. It's a little hidden. Questions with this one? Do you understand why we didn't shade everything? It can't have negative chips, can't have negative pops. So it's called contextual questions, meaning there's a context behind it.
Say we on a test we write, we do all of it, we still get like half marks.
Read to read. Don't overthink. Read to read. Well, did you think the elves were working for free? Come on. Well, really, aren't the elves slaves? Mini slaves, really, when you think about it? Are they? I don't know. They really are. They get no benefits. There's no holidays.
No, they get the rest, they get a little break of Christmas off.
They get 1 day off. That's it. 1 day, you little slaves. Okay, so what's important? Debatable.
10 hours a day.
More important than that is
At most.
at most 10 hours, because that tells you it is an inequality. Could they spend less? But can they spend more? No, we have to give them a break.
CC, they get
10 hours is a pretty long day.
yeah, but they get
Pretty
12
long
hours.
day.
So.
How many hours are in a day?
Oh, wait. 14 hours.
Nope. 5 hours,
Make rocking horse.
2 hours.
Teddy bear. Show all possible combinations. Didn't find it.
Yeah, I'm okay with that. No, because then we'll have to talk about Santa's not real. Need to define your variables. If you miss this step when you did max min problems, you might want to highlight this, put it in red. You have to define variables. You can't just throw x and y out and not tell me what they are. What do you want x to be?
Stuffed teddy bears. 2 hours. Number of hours. Number of teddy bears. Number of rocking horses.
How could you possibly guess that? Fine, how could you possibly know that? Nothing.
Alright.
Okay, let's make the equation. Talk to me about bears.
Well, they're fluffy.
2x
So 2 for each bear, plus 5y, not equals, less than or equal to.
I found out that teddy bears are named after Teddy Roosevelt because he had 2 teddy bears.
I did not know that. There you go.
I remember learning that they were named after Teddy Roosevelt,
Now that we have the equation, we're just following the same steps. What's step number 1? Okay. Flip or no flip? Why no flip? Not dividing by a negative, dividing by a positive. Intercept first. Why solid? So could they spend 10 hours exactly? Yes. Why did I not extend my line? Yeah, so if you did, that's fine. Just I looked ahead and said, well, I know it can't be negative, so I didn't extend. Where are we going to shade? All of below? It would be hard to make negative bears.